Hello everyone, welcome to OneClass. My name is Shanjida, and today I'll be going over some commonly asked chemistry questions, both at the high school / university and college levels. And so basically I am a second year human biology student studying at U of T. And lastly, if anyone needs additional schoolwork help or needs tutoring, you guys could check the description box below. And other than that, we'll get started. So the first question says, what is nickel? So nickel is an element. Nickel is an element from the periodic table, and basically it is an atom also. Atom located in group 10. Located in group 10 of the periodic table of elements, and nickel is one of the transition metals also. So this is a transition metal. It is also a transition metal. Also a transition metal, and which includes elements in group 3 to 12 of the periodic table as well. So if we go over here, this is our periodic table, and we can see that nickel is right here. So nickel also, so the symbolic version of it is Ni. You can see it's group 10. It has an atomic number of 28 and a molar mass of 58.69 grams per mole, or that is also the atomic mass unit. And so you can also say that nickel has, so since it has 28 electrons, it also has 28 electrons and 28 protons. Okay. And so the number of positively charged protons in nickel's nucleus means that the neutral nickel atom have 28 total electrons, which we just mentioned. And when nickel loses one electron, it becomes a cation. Okay, because you know how you lose electrons are negative, so you're getting more positive if you lose negatives. And so consequently, when it loses 2 electrons, its proper name would be nickel, nickel 2. So when nickel loses 2 electrons, it becomes, so you write nickel up like this. Okay. And so these cations easily form ionic bonds with negatively charged atoms and covalent bonds with other molecules forming complexes. So nickel, so nickel 2 can form ionic and covalent bonds. And also one vitally important application for nickel, just background information, is that it is included in the mixture of other metals called alloys. So nickel is used as alloys with other mixture of metals. Okay. And this, so basic example, for example, stainless steel, for example, and requires nickel to be added to a mixture of iron, carbon, and other metals, right? So for example, we can say For example, nickel is used in stainless steel. Stainless. And so this is correct. Okay, so our next question says, what is the name of the compound P2O5? And so since the compound consists of two nonmetals, so we have P, right? So this consists of two nonmetals. So you guys could see that we have two phosphorus and we have 5 oxygens, right? So these are two nonmetals, and so this is a covalent compound. And so you can say two nonmetals, therefore covalent compound, right? And so the name of the element plus the prefix, which is determined by the subscript, right? The prefix is determined by the subscript, which is in this case would be 2 and 5, is used for the second element. So the suffix is "-ide", suffix "-ide" would be used. So for basically P2O5, the first element is phosphorus and it has a subscript of 2, as you can see, while the second element is oxygen and it has a subscript of 5. So the prefix used when the subscript is 2. So if you guys know our Roman numbers, we have it's Roman, yeah. So it's gonna be, the 2 is di. So we know that 2 is di and 5 is penta. Right? So the suffix in this case would be used at the end of the name. So in this case, it would be used at the end of penta. And so what we are gonna write, so basically to name this, we would first, we would first put the prefix of the first element, which is, for the first element, it's phosphorus, and since it has a subscript of 2, it would be di, phosphorus, pentaoxide. So we would get rid of the A, and replace it with an oxide. So it would be pentaoxide. So this is this is how you write out the chemical formula for E2. Okay, so this is only for covalent bonds. Remember, you don't do this for ionic bonds. And so this is correct. Okay, next question says, how can the pH of NaOH be calculated? And so first of all, let's address what NaOH is. So we know that NaOH, this is sodium hydroxide, and this is a base, right? We know that this is a base, and an ionic bond. Or no, Okay, so let's just keep it as it is a base. And so we're trying to determine the pH, and to determine it, we need to know the concentration of NaOH, of sodium hydroxide. So that is very crucial. So to determine in pH, we need to know concentration of NaOH. Okay? This is very crucial. So for any pH that needs to be solved, we need to have a given concentration. That is very, very important. And so, for example, since it's not given, they just want to know the method of calculating the pH. We can say, for example, so they said, for example, we want to determine the pH of NaOH in a solution that is 0.2 molars. So we say the concentration is 0.2. And so first we need to compute for the molarity of NaOH in a solution. And so NaOH is a very strong base. As we mentioned, it is a base and is very strong. Therefore, it will produce 0.2 mole per liter of OH ounce solution. Okay, so when we're trying to find out pH of the substance, we're actually trying to find out the actual base or the ions of that particular substance. So in this case, we're actually trying to find, so actually, trying to find pH of the OH ion. And so we can find this by taking the pOH. So in cases of bases, so for bases, we use pOH. Okay, so this makes sense since we're calculating the pH of our hydroxide ions. And so therefore we can say that the pOH of our hydroxide ions is equal to, so this is pOH is equal to the negative log of the concentration of our hydroxide. So this is equal to the concentration of our NaOH. So we can say this is also equal to the concentration of OH. And so what we can say, we can substitute 0.2 for OH here. So we have negative log of 0.2 of pOH, and what we get 0.2 pOH, and we're trying to find pH, not pOH. And to do that, there is a formula for that, which is, so let's say pH plus pOH is equal to 14. So this is a formula, universal formula. We can now isolate or rearrange to find pH. So we can say that pH is equal to 14 minus pOH, right? And so to do this, we can say, so therefore we can say, find the pH of our base here. We can say pH is equal to 14 minus 0.7, which is equal to 13.3. And so the pH so the pH of 0.2 molars of NaOH is 13. So you can see that this has a big value, a large value of pH. And if you guys recall that, so let's say this is a pH scale, this is 7, this is 14. Okay. And so this is your acidic. So this is acidic. And this is your basic. So the more closer you get to 14, the more basic it is. And so, or more strong of a base it is. So we know that NaOH is very strong because it has a really big high pH. Okay. And so this makes sense. So this is the next question says, what are polar and nonpolar bonds? And so we can, so basically when there are two atoms sharing electrons from a bond, there's a partial transfer of electron density from one atom to another. And so this is where you're talking about electronegativities. And so we know that covalent bonds are bonds where your electrons are being shared, right? Between the two atoms. Electrons being shared in the bond. And so when it comes to polar or nonpolar, so polar, nonpolar, this is where we're talking about electronegativity, okay? Of the two elements or atoms. And so basically when you have polar bonds, or yeah, so when we're talking about electronegativity, there is a certain range where or there's a certain range where an element could basically where an element or when an atom tends to accumulate um more electrons or not more electrons, the electrons. To itself. So what I mean by this is that if an element has a higher electronegativity, so let's say if an element slash atom has a higher has a high electronegativity, it will basically pull the electron that is being shared towards itself. You can say, in other words, you can say that it's stronger, so it pulls the electrons to itself. So it's more, you can say it's more negative, right? And so this is what electronegativity means. And so when you're talking about polar bonds, this is where your electronegativity difference between, so your electronegativity difference, this, so the difference in electronegativity is between, it's between was 0.8 to like 1.2 or something like that. So it's like when you have an electronegativity between this range, it was something like that, and your nonpolar bonds are where your electronegativity difference is like 0.5 to like 0. Or no, it's like 0.2 or something like that. So 0.2 to like 0.6 something. So it's like really less. So the main point is that you basically find the electronegativity of an element. It's given an electronegativity chart, and you can basically subtract or find the difference between the two and see if it's nonpolar or polar. And basically, if your electronegativity difference is greater than 1.2, that's called an ionic bond. And so, let's say, so for example, okay, so for example, let's say, for example, let's say we have methane, which says over here. So methane is an example of a non-polar covalent bond due to the very small difference in electronegativity of carbon and hydrogen atoms, resulting in equal sharing of electrons. Okay, so methane, so it has CH4. Okay, so let's draw out the here, which we have, let's see, H and H, right? So you can see that there are two atoms right here, carbon and hydrogen. And so the electronegativity of, I think, carbon was, so carbon had an electronegativity of 2.8, and hydrogen had a negativity of 2.5-ish. So the electronegativity difference, however, so this is actually given in an electronegativity chart. And so this is, you can probably 0.3. So the electronegativity difference is very low. So this is basically, this is a non-polar covalent bond. And for example, if we have water in this case, so for example, example number 2, we have water. H2O, draw the molecule. It is OH, and oxygen has 3 lone pairs. And so the electronegativity of oxygen is 3.5, I think, and hydrogen is 2.5. You can see the difference is 1, so there is a high electronegativity. So this is a polar bond, and if it is a polar bond, the more electronegative, right, the higher the number. That atom would have a delta negative, whereas the lower one would have a delta positive. And so this is a polar molecule. That was the difference between polar and nonpolar. So it's basically where you have electronegativity included. The solution says, what is thiocyanate? So the polar or nonpolar bond. So oops, we have the N is called thiocyanate. This is a polar bond because there's a great difference on the electronegativity of the atoms. Um, so sulfur, we know that there's sulfur, carbon, and nitrogen. So sulfur has an electronegativity of 2.58. Carbon, right? Stating carbon has 2.55. Nitrogen has. Okay, we can see that nitrogen has a higher electronegativity. So electron. Right, so we can see that nitrogen has a higher electronegativity, so this will tend to pull electrons closer to itself. Okay, so compared to the other elements, so this happens in a polar bond where one atom tends to basically pull the electrons closer to itself from the other elements, right? And we can see that the electronegativity difference between nitrogen and carbon is a lot, and it's great. It's like almost 1, and the same goes for sulfur. So this is a polar bond. This is okay. So the next says, what is the molar mass of carbon sulfate? Okay, so carbon molar mass. So I'm going to denote molar mass as mm of carbon. So what we're going to do to find the molar mass, we're going to break the compound into their individual elements. And so you can see in this case we have 3 atoms. And so first what we're going to do, so the molar mass. So basically the molar mass of calcium sulfate. We're going to break this down into their individual elements or atoms. And so we're going to break this down to carbon, the molar mass of carbon plus the molar mass of sulfur and the molar mass of the four oxygen. Okay. So to do this, we need to first state or know the molar mass of calcium. And so this is given in your periodic table. We move here, we can see that calcium, so this is your molar mass, what's underneath, it's 40.08. You can say this is 40.08 grams per mole. So this is your unit, plus the molar mass of sulfur. In this case, sulfur is right here. There's a molar mass of 32.06. 32.06 grams per mole. And lastly, oxygen. We have 4 oxygens, right? So we would have to multiply the molar mass by 4. So we would have plus 4 times 16.00. And so the last step would be to basically to add them all up. And what we get, so if you add this all up, we get 40.08 grams per mole plus 32.06 grams per mole plus 4. So if you add these three numbers together, we have 136.134 grams. And so the molar mass of calcium sulfate is 136.134 grams per mole. This is what we've got. So the solution is okay. So our next question says, what is the molar mass of aluminum sulfate? So we're given the formula. So we need to find the molar mass of aluminum sulfate. So in order to find molar mass, it's very crucial to know the chemical formula because that's what that's what tells you how many atoms there are in the compound. And so basically what we have to do is break this down into the individual elements or atoms. And in this case, you can see we have 3. We have aluminum, sulfate, and oxygen. We would break this down. What we're trying to find. So the molar mass, or break this down to the molar mass of aluminum. So aluminum sulfate, right? We break this down into the molar mass of aluminum plus the molar mass of, in this case, we have 3 sulfates. And we have 12 oxygen. Molar mass of 12 oxygen. So the molar mass of aluminum, of 1 aluminum atom, so that is 26.98. We have 2, so we would have to multiply that by 2. 26.98 grams per mole. And then you would add that with the molar mass of sulfur. This case is 32.06, and we have 3, so we multiply that by 3. 32.06. Lastly, we have 12 oxygen, so we would multiply that by 12. So the molar mass of 1 oxygen atom is 16. multiply that by 12. Okay. And so lastly, the last step would be to add all of these three numbers together. And what we get, add this all up, get 342.132. So the molar mass aluminum sulfate is 342.132 grams per mole. And so the solution is correct. Okay, so our next question says, which of these molecules are polar? Check all that applies. So we know that polar molecules must contain polar bonds as a result of non-zero net dipole moment due to their presence of partial and negative charges. And so a polar molecule with two or more polar bonds must have an asymmetric geometry. And so where the bonds don't cancel out the dipoles. And so let's say, so in the first case we have, let's say A, we have CO2, right? Carbon dioxide. And so the structure for this is C. Okay, as you can see, this is not asymmetric, this is symmetrical. So basically, this is your delta positive. So and so you can see how the vectors cancel out. So this is symmetrical, so this is nonpolar. So now let's see where, which is SO2. And so SO2, the way you would draw this is and I would have this case and in this case alpha would have two lone pairs, and in this case this is not symmetrical, as you can see it is bent. And so this is polar. Okay, and it is a bent shaped, and the electronegativity difference between sulfur and oxygen will create a net dipole. So okay, so this, since it's bent, it will create a net dipole. Okay, so let's see, we have CH2 and Cl2, right? And so this is polar because of its tetrahedral shape. So this is a tetrahedral. So we have C, H, okay. So let's see. Cl. And you can see this is a tetrahedral shape. Hedral, and so this is polar. Okay. And this is asymmetrical, right? So then our next one, last one, is PCl3. And so this is polar because of its trigonal pyramidal structure. So the way you would draw this is so PCl. And so this is polar because, so this is the trigonal planar or pyramidal. And so for this is polar. And so the net difference between the electronegativities is also big, is also significantly large. So this is why it's polar. And so the only nonpolar was CO2. So the solution here is correct. Okay, so okay, so our next question says, how is Q is equal to MCT used? Okay, so the question, so the equation, so we have an equation where Q is equal to Q is equal to MC delta T, and where Q is the amount of heat in joules, so in joules, and your M is the mass in kilograms, and your C is the specific heat capacity, so and this is in joules per mole per mole Kelvin. Okay, and the temperature is in Kelvin. And it is used to determine the amount of heat involved in changing the temperature of a substance of one mass. And so it's basically used to determine the amount of heat involved in changing the temperature of a substance of mass m and specific heat capacity. The positive value of Q indicates, so let's say Q, so if Q is equal to a positive number, this means that the energy is absorbed, means energy is absorbed. And if Q is negative, this means energy is released by the system. So this is basically it. So basically, we know that it is used to determine the amount of heat involved in changing the temperature of a substance of mass m and specific heat capacity for the system. And so basically, that was the end of our session. If you like this Q&A, please subscribe to the OneClass channel, comment, and share this video. And if anyone has personal questions or needs one-on-one tutoring services, you guys can check the description box below and ask your questions. Other than that, I'm Shanjida, and I'll hope to see you guys soon. Bye-bye.